Hello, good morning to everybody. I'm Carmelo Di Pasquale from Nippon Gas Italy, and today we'll speak about innovative solution for energy efficiency of HVAC and R systems. Just a brief introduction of our company. We are a multinational company that we are with a worldwide presence all around the world in 5 continents. We are a part of the Nippon Sanso Holding Corporation based in Tokyo, and we are present in all 5 continents, and our main business is the production and the distribution of industrial gases, medical gases, technical gases, cryogenical gases, special gas, and also refrigerant gases. In Nippon Gas Italy, we provide also gas service, materials, equipment, and facilities. For what concerns Nippon Gas refrigerant business in Italy, we have 2 distribution plants, 2 filling stations in North Italy, and we collaborate together with our partners, Chemours, Honeywell, Daikin, and Arkema, to develop the new HFO products inside the Italian market, both in commercial refrigeration, industrial refrigeration, and air conditioning. And thanks to our widespread network sales, we are able to deliver our products and our service in the quickest way. Just a brief introduction of the F-gas regulation, the new F-gas regulation. With the blue line, you can see the previous F-gas regulation, but now in 2024, it's entering into force the new F-gas regulation that is more strict. There is more face-down quota cut that is triggering a lot of impact inside the market. For example, the price of the refrigerant gas is going higher, but also the availability of HFC with high GWP refrigerant is going down. So now we see in this 2 years, between the 2023 and 2025, now we are focusing about the higher price and less quota cut. So we in this slide you can see the key points of the newest gas regulation that is very strict. For example, we see a lot of stricter GWP limits in both commercial refrigeration and air conditioning segment. The stop of the use in R404 virgin for maintenance from 2025, so next year. The GWP limit is 150 in commercial refrigeration. This point is very crucial because it's allowed to us to develop a new product inside the market. So not only natural refrigerant, but also A2L, HFO refrigerant gases for the new plants. The F-gas ban in heat pumps with capacity below than 12 kilowatt since 2035. This is another important aspect because this will be impact the development of the heat pump with propane. The payment of the additional fee of €3 per ton of CO2 equivalent. This is an incentive for the development of a new product with low GWP. The new law enforcement measure to prevent illegal HFC, because this very strong quota cut will impact all the market in terms also of illegal HFC trade, most of all in the south part of Italy. And the importance of EN 368 standard regulation for the development of new flammable products, because as you know, the new refrigerant gas with low GWP are all flammable. So we need to respect the limit charge to be compliant with the regulation. Okay. This is here in this slide you can see an overview of the refrigerant that is impacting our market, and it is divided by the pressure of the refrigerant. For example, for high pressure scroll compressor, the transition from 410A is going to R32 and R454B for heat pumps, for example. In a medium pressure from 134A, we are going to use 513A for retrofit and 1234ZE for the new chiller with the large chiller, for example. And in refrigeration, the retrofit, you can use 448, for example, for the retrofit over 404, or going with the new refrigerant, A2L refrigerant, or natural gas. So the transition must accelerate to allow the transition to low GWP refrigerant. As you know, on the left side, with these 4 refrigerants, ZE, 455A, Optonic Cell20 and Optonic Cell41, you can cover all the applications inside HVAC and R market in long-term solution. So it is a valid alternative to natural gas. Another important factor is that the best shoes for the development of a new plant in refrigeration, in commercial and air conditioning is not only to see the best GWP, the less GWP of the refrigerant, but we have to analyze all other factors, for example, the cost of the investment, the operating cost, and also the total equivalent warming impact. This is the most important factor, because we are not only focused about the GWP, but only the indirect emission of the system. This is an important case study that we developed together with our partner Chemours and in collaboration with Polytechnic of Milan. We take in consideration a small medium supermarket of 1,000 square meters, and we did a numerical simulation in which we compare HFO indirect expansion with the 545C of Chemours with an internal heat exchanger, as you can see, and on the other side, a normal transcritical CO2 booster compressor with the parallel compressor. And we analyze the performance analysis throughout the years in two different points of Italy, in North Italy and South Italy. The result was very impressive because, as you can see here, after the simulation of the study, we have less annual consumption, electric annual consumption with the 545C, because it's not a big supermarket, but it's a middle-mall supermarket. And this gap is stronger in South Italy because due to the low critical temperature of the CO2. So the energy efficiency for this small segment, for this small application, is better for HFO than CO2. CO2 is going good. It's a good solution made in the large retail trade for supermarket, for bigger supermarket or for surface supermarket. For what concerns the other topic that we are going to develop with our partner Alperia Green Future, we are also developing not only the new refrigerant gas, but also new service. We are going to develop a new energy efficiency service in collaboration with our partner Alperia in order to increase the energy saving and reduce maintenance costs of our customer plants. The most important things of this system that we are going to develop is the heart is the Sibyl system. Sibyl is an intelligent control advanced system that work with machine learning algorithms that are able to predict the cooling and heating demand in the refrigeration circuit, and also to prevent eventual breakdown in the system. So it's a very flexible, because this system can communicate with all the common latest BMS system, for example, Modbus or BACnet, and is proactive, is on time, and can control all the variable and all the set point of the system. This is a typical architecture of this system. For example, here you can see in a process cooling system, for example, where you can have 3 chillers, 2 air-cooled chillers, 1 water-cooled system with the cooling tower. And here you can see how Sibyl interact with the inverter of the compressor to optimize the evaporation pressure, and also the fan of the cooling tower. So Sibyl also is able to generate a report, control the alarms, and sending the report, and also have a web interface, of course, because it's communicating Modbus with the BMS. So this is a common architecture of the system. And now we see some case study where we have some reference after the installing of this system, a very important reference in which our customer achieve a lot of energy saving during the year. So we have some reference, for example, in the airport, in the business center, and for shopping center. For example, we can start with the first case study, that is a shopping center in North Italy, when you can have 36 shops and 3 common areas. The HVAC system is composed by 3 air handling units with the heat recovery system, 10 primary air handling units for shops, a 3 air-cooled chiller with a capacity of 260 kilowatt each, and there is also an existing BMS system of Emerson. On the right side, you can see the graph of the modulation of the fan in base of the set point, and below you can see also the console of the Sibyl system with the water leaving temperature of the system in base of the time slot of the day. So you can see when you need more load, the system is going to push to 8 degree leaving water temperature. In other part of the day, Sibyl automatically will change the set point. The results in 1 year are so impressive, because after the installation of the system, you can reach up to 11,000 standard cubic meters per year of gas saving, 93,000 kilowatt per hours of energy saving that are equal more or less to 47.3 tons of CO2 emission avoided. So this is the first case study in which we installed Sibyl. In the second case study, that is a business center, we have a different system because we have a 4-pipe system here with a multi-purpose chiller, 7 boilers, 223 fan coil units, 20 heat recovery units, and there is an existing Siemens Desigo BMS. On the right side, you can see in the graph the modulation of Sibyl. So in the left side, the Sibyl is off. In the green side, the Sibyl is on. And here you can see how the Sibyl system modulates the set point in order to have less fluctuation of the system. Also here, the results in 1 year are so impressive, and is with the result of a good energy efficiency system. Last but not least, there was an important case study that was done in the Venice airport. Here it was installed a Sibyl system in 40 air handling units that control the flow rate of the plants. Here the criteria was different. Here was taking into consideration the traffic of the passenger throughout the days. As you can see, the Sibyl modulating automatically the flow rate of the air from 10 of the morning to 8 in the evening, because it's the time slot of the day when you have more traffic passenger. And consequently, you have also here a good energy efficiency of the system with a good result. So in conclusion, we can say that training on use, transportation, and storage of flammable gas is so important for the generation of the next refrigerant, because for the next refrigerant generation, because we have to spread out the new regulation, the new flammable gas that are different to use to the previous HFC, because are not flammable. The transition to low GWP, A12 refrigerant or natural gas must accelerate, because there will be a risk of HFC shortage after 2027 due to the strong quota cut of the new gas regulation. Low GWP A12 refrigerant as candidate as the best solution in terms of energy efficiency for commercial refrigeration system and for small, medium-sized retail trade, but also for the cold rooms in a lot of application. There is no single refrigerant suitable for your application. In base, if you have a small supermarket, a medium supermarket, a cold rooms, a direct expansion system, you have to evaluate the best refrigerant in order if it's flammable or not flammable. Refrigerant gas reclamation is essential process to secure the market volume as a result of the large share cut expected in the coming years. And last but not least, with our new energy efficiency service, Nippon Gas, in collaboration with Alperia, gives the opportunity to make plants more efficient thanks to the installation of this important advanced control system that is able to predict cooling and heating demand of the system, giving a lot of energy savings to the customer. Thanks for the attention. If there are some questions here, I welcome you to join us at our booth here in Chilventa for more information. Thank you a lot.